of this second class of Introduction to R. And today I am going to show you my dissertation project, PhD dissertation, how I am working on it. And I hope that it will be more helpful to showing the real examples. And also, last time we went through the steps, how do we install the R, what are the components like the R programming language itself and the wrapper of the R Studio that you need to install on your computer. And after that, I showed you how I organize my working directory. And also I'm using actively the AI there, and the one that I'm using currently is the Claude AI. So let me show you how this Claude AI looks. This is, this AI, Claude AI, which is currently one of, the strongest regarding the coding. So you can prompt him what you want, and he will get you the best code out there so far. So what is the workflow here? So here, as I described before, on the right bottom side, we have a directory structure. What folders we have. So here I have organized my project, the dissertation, and the key files here are the env file for the passwords, credentials, anything that I need to connect remotely. Then there is this CloudMD. These are instructions for the Claude, which are written in human language, divided into sections, and they explain what is responsible for what. So general description of the file, how the credentials work in the env file, where he can find the password and login for later use, and in the order of the execution. Also, I have this README MD, which is for humans mostly. The description of the folder structure. We have docs for the manuscripts, slides, figures, tables, code where we plan to put the SQL, R, the data that was downloaded from the database, processed and saved in temporary CSV files and others, and the output folder for the CSV tables that we got as a summary of the data, and literature where I plan to put some papers that I want that I'm going to reference. Here, my dissertation topic is strategic models for economic sustainability in public procurements. I have collected data from goszakup.gov.kz. I got the token. This is the standard process. You can write them official letter, and then they will send you the token. And you can use that token to access their API and download whatever amount of data you want. You just need to organize it. I have organized it in separate web project which is written in PHP, but I think there is no problem writing even that in R. So you could go to the API. It has a documentation how this works. So here they describe how you get. In order to get, you will need to write the letter in this template, and then you can access these sections. So participants of public procurements, plans, announcements, lots, and so on. So everything is there. And the data starts from 2016 and it is ongoing. So we have more than 10 years of data. And still, I think there is a big amount of things that you can do with your ideas. You can collaborate with different areas, like we do with Dr. Borjan on decentralization, where we research on the behavior at regional level, how the administrations at local level do their procurements, when do they do it, what is their fail rate, how much budget they allocate year by year. So all of it can be collected from there. So I have put it in the database, which is in MySQL there, and using AI, I have organized it. So yeah, let's get back a little bit. So here I have this README, and the main file is the plan MD. This one was generated by Claude itself. I asked him, like, describe in words what I want briefly. So I want to write a dissertation with 3 chapters. First one is literature, theoretical framework, and so on. Second is data, methodology, analysis. And the third one is results, discussions, policy implications. So, and then he, usually when you ask it, he creates it in his own understanding. Like I asked him to reference to the best practices out there, and he creates his own structure. And where needed, I can ask him directly or do the corrections myself. Like here, I can change any word what I don't like, or if I see some mistake in interpretation, I talk with him. So here we have brief description of what we have there, and then there on our last meeting with my supervisor and Dr. Borjan, we decided that we need in this dissertation to use few models. So after we collected data, we decided that we want to have the models like zero inflated negative binomial for the count data. This is a little bit different from ordinary least squares, but the general interpretation, everything is the same. So you don't need to get deep right now into the maths of it, because AI can help you to use it. But before you start it, of course, you will need to do descriptive statistics to understand which model fits your data the best and connect it to the theory, and then you can confidently go with that model. So first model is zero inflated negative binomial. Here the research question is, what drives the competition intensity? So what I do, I take the data in the dimension of number of bits in different lots. So what is like, some bits are interesting. Let's say there is a building of a road, like for 10 million or 10 billion tenge. Then there will be 20 participants. Let's say then there is a procurement of these tables. This kind of a table, just one table, and the price is, let's say, like if it is, its real cost is 500,000, and they ask, we are ready to buy it for 700,000, then the profit margin is small, then we expect that there will be a small number of people who bid there. So this is the competition. We view it as the more participants are in the procurement, the more it is attractive. So here we've defined this as a dependent variable is the number of participants, and independent variables are capital 2-digit is the coding of region. Which region out of 20 regions, like Astana, Almaty, Karaganda, and so on. These are encoded in first 2 digits of the Kato code. Then there is industry, ENS true. This is a coding of goods, services, works, and which category is it. We also group them as it is hierarchical. For example, 10 is for, I don't know, building materials. I'm not sure, but something like that. Like anything, cement, steel, and so on, and so on, all the other categories. Then there is this subject type. It is either goods, works, or services. This is a categorical variable, which is like maybe you have covered the dummy variables, where we create the vector of dummy variables for each category. So 0, 1, 0 if it is not goods, and for works it is like 1 if it is works, 0 if it is not works. So we have 3 separate variables and so on. Then reference of administrator, the organization who administers this budget, like there are different budgets, different programs, national programs, financing, for example, building schools. So there is a single organization who administers it. The expectation here is some administrators are more effective and they attract more competition, and while others, they don't have much budgets, so they don't attract more participants. Or maybe they have good practices and bad practices in procurement organization, maybe in documentation part, or maybe they are hard to get final documents on, like they don't like to accept it and so on. Then lot amount is the allocated budget, how much money they ask for it, for each lot. Then there is a count, number of items they are going to purchase. So this is the first model we are going to generate. Then next model is the what predicts a winning bid. Here we look at different dimensions. We look at the at each bid, where company, for example, you are a supplier, you put your bid, like I want to supply you with A4 papers, and you fill your data. Here we look at you as an organization. What is your experience? So how many bids you did before? What is your win rate before? Like how many bids you got, how much you won, and so on. So we look at the organization level data. Here I use the model which is called logic. Logic is for when our dependent variable is binary, like it is either 0 or 1. So if your bid is successful, then you won, you got your first place, and you got the contract. And here we also do the same regression. We get the coefficients and we interpret how much these variables affect or do not affect, and to which sign to predict the probability of winning. Then the optimal bidder count. Here we have simple Euler's regression, where we use one variable 2 times. It is the number of bidders. So here we look at again at the dimension of each tender, where we have allocated budget and the winner's sum. So the difference is how much money was saved during the procurement. So logically we expect the more participants, the more is the saving, right? So for example, if there are 20 participants, maybe the winner will be giving the 50% discount to the lower than the allocated budget. So 50% was saved. So here we try to find what number of participants maximizes this number. We could expect that it should be the more participants, the lower is the budget, right? But also there is a thing called diminishing returns. So it grows, gets lower and lower, and then at some point this effect doesn't add anything. For example, at 101st participant doesn't change anything. As it was around 50%, it stays there. So here we are trying to find what is the optimal number of participants that maximizes the saving. Then there is a fourth and fifth models that I'm still. Fourth model, this one is, I'm not sure which model will be used, but here the logic is we are going to divide the suppliers into groups. So there are some suppliers who are like effective, they are best performers. They, for example, participate in 10 tenders and they win 4 altogether, and which is a good result. Then there are other participants who bid like on 1,000 bids and win only 1 or even don't win anything. So they are clearly losers. And if you are a loser and you don't get like money from this business, you are going to be out of this business very soon, right? So here we try to identify the groups of losers and winners, and then find what distinguishes them between each other. So, like, what patterns have those who win? Like, how do they do? Should they? Here we will refer to the previous variables. But this model will be clarified a little bit later, so we will get there after we have these results, and we can connect those first models as a base, and then go here to this model number 4, supplier typology, to see how they differ, which supports, which affects them. So in order to get to the topic of economic sustainability in public procurement. So in order to find what makes companies economically sustainable in public procurements, we need to find their patterns of behavior. And the last model is survival analysis, which is also an interesting one. This is absolutely not it is not regression, I think. And I still I didn't do this model yet. I will learn it alongside. But the idea is we have companies, and at some point they stop bidding. If they stop bidding, it means they are not active in the business. So we can flag it as the death of the company. How long it should be? For example, it could be 12 consecutive months that they didn't bid. So we could say if they didn't bid for 1 year, then they are dead. Maybe there is a 2-year gap, to consider them dead. But we will need to see at the descriptive data how much companies will be in this side and in this side to see the good proportions of alive companies and dead companies to distinguish between them, and then we will again see how long do they live and what drives the what companies live longer, what companies live shorter. So this is another dimension for the sustainability. So they should a little bit intersect with each other, but overall this gives us analytical output that we can use in our research. So then I have this plan, which is also written with AI. So here are my current real-time plan, what I need to do. Every time I execute some code, I tell about it to the Claude, and he updates it. So and the code itself looks like this. So Claude is the terminal interface. Actually, you can use old style or a little bit more user-friendly design like this. This one is cursor. This is for coding. But as I have organized my folders in this structure, it is really helpful. So we can view it like here. It is a little bit similar to the RStudio's visuals. But what it does, we have the chat on the left side, and we can talk about describe me the project for workshop participants. So, yeah, it is like talking to the AI in the chat GPT or in the web browser, but here it has access to the folder of the project. So this way it is more convenient. And yeah, we can talk to it, we can ask any question. When we get the idea, we can ask him, let's make some changes to the project. So this is, yeah, actually this one is user-friendly, so I strongly recommend you to download the cursor and put the project there and try playing out with this one. And also, yeah, I will try to not forget to send you the access to this project. Yeah, also I'm working with this project in the GitHub. I will not like walk you through how to work with the GitHub, but briefly, this is the repository for the projects. So here, my dissertation. So why is this helpful? You just store your code, all of your work in the cloud. This is useful, and also when you want to collaborate, you can give access to your partners, and also you can make it private or open the project so you can share how this works. Yeah, still, as you see, I didn't upload all the latest changes, but I will do it later. So let's get back. So this is the standard workflow, and now I started working with the Cloud AI because it is what is the yeah, it is much simpler. Like here in this interface, I need to work with multiple windows, talk here and look at these changes, which is more useful in coding process rather than writing. So I prefer to work here. And also with the like bright color coding helps you read the changes and so on. So how this process is organized? This is just a long chat log, like when you talk about the project, and it has all the access. What I do here is I describe him what I want. Here, yeah, here I have copy-pasted the errors, error outputs from the R, what didn't work, and he returns me like what should be fixed. So he shows exactly in this file 04 core dataset on 101 first line. We need to remove this line and change to ref Kato code. So just one small change to fix the problem that I got here, because it didn't know what the problem was. And then I run it again. And it still didn't work. I again asked him to fix it. I put the output. Then he shows what's the problem. And he lists the problems, and then he suggests some fixes. So in the end, we got to the point where this everything works. So here it was the stage where I ran the codes from 0, 1 in R. Code. So 0, 1, this one is descriptive dataset collection. Description of the database, not the dataset, but the database, like what columns we have, what fields, how many values are there, and so on. So it saves those files into the folder. It is in the output tables. So here in the output tables, it put files like this. This CSV shows total participants is 639,000 records. Then next question. So all of this turns into the context for the AI. Then like if it is trying to work like or create new code, it can directly refer to this file, find what is the general description of the dataset, and then decide. So here we have very big, like 350,000 of them like this, and it will consider the load on the code. Like we don't make too many operations on this data because we can see that it might take longer time, or it can get to the memory wall that your computer cannot work with that. So it was one of the cases actually when my computer went dead because of it was trying to process 55 million records of bits, and then I showed that it doesn't work, and he optimized the code, used the different library. And also thanks to the models type, like Opus 4.6. Opus 4.6. This one is the strongest. It has got the right library and fixed it. Although I could go with like simpler models like Composer or I don't know, ChatGPT's simple models, it would take like maybe 10 tries in order to fix them. So this is the general difference. You can save money and go with the free version and do it in 10 tries, or you can save time and do it in like 1 or 2 tries, the fixes. So general difference currently among the models is this one. So then, after I did the descriptive part, we got this further description of the database, what fields we have. Then we got to the third script, which shows the reference tables, which values we have before we get the main data set. And then there is this code, core dataset, which is used for the descriptive part. Finally, we got to the descriptive part of the dissertation. So here we collect detailed data with which we are going to run the regressions. So here we collect data for the first model, second model, and so on. Then here we get to the point of descriptive stats. Here it generates the tables that later can be used and put directly into the paper or into the dissertation, and we can decide which is better to use at the time, whether it is a raw table or it should be a graph or whatever. It will be used in the next part, like 06 will be graphs. Graphs and tables will be generated in the good format. So, as I got here, and after I got the discussion on which models we are going to use, I decided like we have collected some amount of data, but we don't have single narrative. Like, what is the story? So, the good papers that I have read from like Scopus Q1 level, they usually have very beautiful narrative. When you read, you feel it like a single story, not just like I use this model, I use this model, but a single story. So in order to do that, I got with the idea for the Claude to let's create this file and let's call it narrative. Yeah, before I discussed like, is it a good practice or not? So he said, yeah, this is a good way, and we keep it as a separate file. So the idea is, so far, what the data shows. And we got few like main arguments that are going to be connected. Yeah, it got 8 threads, and this is the whole story of the dissertation. So, or you can consider it as a content, maybe brief description, but later, for the main paper, it will be filled on each side, in each section, and there will be graphs, tables, and it will turn into a 150 pages dissertation. But the main idea, you can understand it from here. And this is the file that will be constantly changed, updated because of like new findings or new ideas. And this is the workflow that I recommend you to try in order to memorize how this process works. So when you are going to do your like midterm projects or final projects or whatever, or maybe I hope that you will try to write some student papers in conferences. So when you do that, and in order to make it interesting for yourself, after you build all the technical parts, like the description of the data and so on, create this narrative and work with this narrative as a file, because it is a solid file. This is as a solid memory of the AI. And when it will like do any work, it will first read out this file, compare it to his like current context and this memory, and then he will decide whether he needs to update this memory if there are new changes that you are prompting, or like restrict himself with like, we don't need to go outside of this narrative. This is our story. So it will be again back on the track. So you have this single story. Yeah, these are like main findings that I'm currently working with, and I feel, yeah. So I hope to get some feedback from you, from others, because this is new for me. These are the things that I just read on the like current best practices in the internet, like how to effectively use AI for research. So these are one of them. So I got too deep into the description of all of it. I would like to have small maybe Q&A session in order to get some feedback from you. So do you have any questions? Maybe you want to focus on some parts of it, or you want to see like practical steps.
Finish? Maybe one visualization that you do. There's something that you
currently generating the table. Okay, so let me show you the steps. How do we work with the Claude code? So first of all, you will need the Claude account. You will need to download the Claude code. Yeah, it will be there. Then after you download it, you will need to organize your folders. After you organize your folders, you go to the PowerShell in Windows or terminal in macOS. After you install the Claude, it will be available here. Like you can type Claude help. Yeah, and it describes what you can do. Next, I need to go to the folder of my project. So here, this is the folder of my project. After you get to that folder in the terminal, you type just Claude. Then you enter the terminal user interface. So let's say we have run the code 05 descriptive stats, and I want to get some visualizations. Let's build 3 graphs for descriptive part according to our narrative. Which ones would be better to start with? Yeah, this part is the same as you write in the, like, this is prompting skill. So you read the same things, but in the terminal interface. So what it does here, as we can see, it is reading for the tables, CSV tables that it is going to process. And here, as you see, it is thinking, and it will soon return. Yeah, here it has suggestions. First, let's see speed volume. Okay, so here he suggests want me to write 06 visualizations are. So first is bid volume by procurement method by year. Looks interesting. Supplier entry cohorts, also good, and win rate distribution across suppliers. I think really super interesting, and I will use it definitely. Okay. So it is writing this 06R code. Yeah, and when you give him like some difficult tasks, you can go and drink some coffee while it is working for you.
In this window, we can change models on.
Here in Claude, it like the setup is default to the Claude Opus 4.6. So it uses best model. Yeah. It currently it writes Sonnet. Sonnet is a little bit different. It is more like it is better for talking. Opus better for coding. I don't know. Maybe under the hood it decides which model it needs to use. Maybe I will need to change model like directly, or maybe I'm going to the limits and that's why I switched to the different model. So as you see, it takes up to a few minutes and it shows how many tokens it did spend. So far, as I am working with it, I am on the $20 plan and I still didn't reach the limit. So I think it has like enough space to use it. Just try to be efficient if you can. So here it says, this is the generated code. And it will draw us the graphs. So let's say just yes, yeah. As you saw, it gives the options like yes, yes, allow always, and no. I don't click on yes, allow always because I don't trust him yet too much. So I want to be sure that he doesn't change my credential file or steals my passwords. So here we have our 06. Let's open it. Yeah, it just writes the code. It doesn't execute it. So I will need to open the code in R. And here is our 06 code. So let's see, do we have all the libraries? All the libraries are turned on. Now we organize the folders for output and for figures. We create the folders if they don't exist. And we define the function that will save the files into those folders. And here, our first graph insertion. Let's make this window bigger to see if there is any error. So there is no error. And we color collect the method colors. And figure one.
It saves everything in the folder, right?
Yeah. No, it is still setting up. Here you see this is a theme. Like for all the graphs, it is going to use these colors. Actually, this is a good practice. Like design-wise, you should use same colors regularly. So if you don't like them, you can switch the colors later and rerun it. So figure one data, figure one plot. And so let's find this file. It was saved. It is in the output table's description. Maybe this will be easier. Tables disk. Here it gets the data, and here it output figures. So here we got our first graph. So yeah.
That's not reasonable.
Yeah, here this one is questionable why this method wasn't used in this period. We will need to check it later, but logically it looks more or less fine. And here the volume is like how many? Okay, yeah, I think I will need to rerun it because now in the workflow of working with the AI, you spend a lot of time analyzing its output. And it is, for him, it is very easy to like generate you tons of text and you will need to sit and read it. So sometimes the helping thing here is things like sanity check. So sometimes like I get too lazy reading it or I get suspicious, like, are you sure that everything there is okay? Then he suggests like, let me generate sanity check code. And then he looks for the like outliers, some extreme values, and then he self-checks them. And then I put the output there and he finds at least some obvious problems that are there. And else you will need to read again deeply to find some problems. But still there is no problem with that. I found like few problems yesterday and I just told him directly in the chat, like I found that there is a problem with this code, and he updated the narrative file and plan file descriptions of the fields, like they were actually not this kind of discount, but this kind of discount, and it was fixed. And logically, I can understand, like I need to rerun from this step. And thanks to having and keeping all the code in the chronological order, you can find where you need to rerun all the steps. So the first graph looks a little bit difficult to like evaluate right away. So let's try to run all other graphs. So let's see supplier cohorts. And it was easy. Next. So let's see other two. Here we have the new supplier entries. Actually, in the data, there is a field called reg year, like registration year. But as I found, it was distributed like the year of registration of the company. So I understand that it doesn't fit to our data, so we decided to use the first bid time. Like if company bid first time in this year, then we look at it that it was registered in this year. Yeah. So here we got the data. We can be confident in the data because it was run by R and it was saved in the CSV file, like from MySQL query to the CSV. And now the same R is turning that CSV table into the graph. So as we can see, there were waves of new registrations on the public procurement portal, and this is pretty much analytical, I think, and it can definitely be used. But as we can see, there are small problems like with the placement of the text. It can be fixed. Yeah, maybe if I decide on the color coding, I will rerun it. So far, it looks nice for me. Yeah, I will need to look at the dissertation requirements for how it should be built. Then I will fix these things later.
Which can we change x-axis if you had negative false conditions? Or is automatically create this one?
Like you can focus on here in this code. So you can dive deeper into the code, understand each line and do the changes. Or you can experiment by playing with the values and adjust it. Or you can say like in graph 2, the text overlaps with the bar.
Well, does it allow, for example, if you saw a nice graph, or let's say you have a dissertation, somebody else said, according to the requirements, if you screenshot it and put it into clause and so generate like the same format, does it work with both?
Yeah, I think it has. There is no problem with making this way. Yeah, because we have, at least in the web interface, we can put the images, and in the terminal version, we can put the file directly and say him, look at this file and try to replicate it. So here he suggests updates. Then we rerun the graph 2. Figure 2. So here we can run all of the parts. And it was saved already. Yeah, here it has fixed. So
Learn cloud code.
all
Intents and purposes.
yeah, I will make the GitHub repository like public. And there is no my data, just the code how the structure works, because the data is too big to store in the GitHub. Maybe if you request, I can share